Hello everyone. Let us solve this question in physics dimensional analysis. Alright, the question asks us to find the dimension of the following: acceleration, velocity, force, pressure, and density. Alright, let us get started. So let's start with number one, which is acceleration. Acceleration, which is denoted as small letter A. Alright, before we can solve the dimension of acceleration, we must know the formula and we must know the unit. All right, which is expressed as change in velocity all over time taken. Now, velocity, which is measured in meter per second, and then time, which is measured in what? In seconds. So looking at this, we have it as m over s, then divided by s. So, and that can give m over s, then times 1 over s. And a, which is acceleration, is going to give us m times 1 will give m over s times s will give s squared. So the unit of acceleration is measured as the unit of acceleration is meter per second square, or can be written as meter per second square. All right, looking at this now, if we still want to calculate or solve dimension, we have to consider what we call MLT. So this M will be representing, this is mass, represent mass, and this will represent length, and this will represent time. All right, so anywhere I found mass, which is measured in kilogram, and then this in meter, and why this in what? In seconds. So I'll be making use of this. Anywhere I find mass, which is in kilogram, I will represent it with M. Anywhere I find meter, okay, which is length, I will represent it with L. Anywhere I find seconds, okay, I'm going to represent it with what? With T. I mean time, which is seconds. I am going to represent it with what? With T. All right. So with this expression, we should be able to find the dimension of each of the uh, above questions. Okay. Now, looking at this, we have m. Okay, let me write it there because of space. Meter per second square. So looking at it now, meter, which is L, then over S, which is what? Which is T square. And this is going to give LT2. So this is the dimension of acceleration. All right, let's go to number two, which is velocity. All right, velocity, which is equal to which is denoted as V, and that is going to give distance over what? Over time taken. And distance is measured in meter, and this is measured in seconds. So this will give us meter per seconds. So here, anywhere we find meter, we represent it as L. Then all over seconds, which is T. And this is going to give L, then T inverse. Never forget, if we have 1 over x is equal to x squared minus 1. All right. So number three, which is force. Force, which is denoted as F. And we know that force is the product of mass and acceleration, which is equal to mass multiplied by acceleration. So mass, which is measured in kilogram, then multiplied by acceleration, which is measured in meter per second. So looking at this now, kilogram multiplied by, and this is going to give us kilogram meter per second. All right, kilogram, which is denoted as m, okay, m, which is denoted as L, all over S, which is denoted as T, okay, and this is going to give us m L T inverse 1, and this is the dimension of force, okay. Let's go to number 4. Number 4, which is pressure. Pressure, which is equal to, which is denoted, okay, which is equal to force over area. Okay, looking at this, force, we've known force already as m L T inverse 1 all over area, which is length times breadth, okay, which is going to give us m L T inverse 1 over, this is measured in meter multiplied by meter, which is meter times meter, which is equal to m L T inverse 1 all over meter square. All right. So looking at this now, I'm going to have it as m L T inverse 1 all over meter, which is denoted as L square. So it will be represented as what? L square. So here we are going to have, let one L goes in L square. So we are going to have m T inverse 1 all over L. So therefore, we are going to have it as m T as 1. Okay. Now we are going to have it as m. By the time this L move down, move up, it will give L inverse of 1, then T inverse 1. And this is the dimension of pressure. Thank you. All right, you can also drop the dimension of density in the comment section. God bless you. Thank you for watching. Bye.